Welcome everybody. Today I'm going to talk to you guys about something that we can use to make Newton's second law a little bit more useful for us. So we have to start with Newton's second law, which, if you recall, is the net force, which is equal to the mass times the acceleration. Now, I don't know about you, but I don't really think about the world in terms of acceleration. It's hard for me to wrap my head around it. And just as an example, think about how many of your classmates have had problems with the units that are meters per second per second. It's not something that the human brain really thinks very easily in. So it sure would be nice if we could think in terms instead of the change in velocity, because I think we all think about the change in velocity when we're driving a car or on a roller coaster or whatever. Anyway, so let's go ahead and get rid of the acceleration idea in there. I think this will make life a little bit easier for all of us if we do that. So if I take the net force is equal to the mass times the acceleration, I want to get rid of the acceleration. It's easy to do it if I just plug in the acceleration definition formula, which is a equals delta v over delta t. Delta v is the change in velocity, which is really what we want to include in this formula to make it a little bit more user-friendly. And so if I plug this in, I end up with this. The net force is equal to the mass multiplied by the change in velocity over the change in the time. Now, at first glance, that doesn't make things easier, but I think it will if you think about the fact that now we have both the change in velocity and change in time in there, and that makes life a little bit easier. Watch what else I can do with this. If I take this formula and rearrange it just a little bit, I'm going to group. I'm going to have two groups of things that I think will make sense to you as you go through it. So I know this doesn't look like I'm simplifying the formula, but if I take both sides and multiply by delta t, I end up with a new formula that looks like this. The net force times the change in the time is equal to the mass times the change in the velocity. I know that formula does not look any easier or simplified in any way, but in reality, it's actually a lot simpler to use this formula than it is to use Newton's second law. And so this is the one that I go to every time I need to talk about it. Now, why are the net force and the change in time on the same side of the formula? It seems like they're not really related. Well, the answer is that actually they are very closely related, not in their units, but in what they do. And so if I want you to just think about something for a second here. If you had a box and you wanted to get that box to slide as fast as possible, I think you'd agree that the easiest possible way is to apply a large force. But if you couldn't apply a large force, you simply weren't able to, there's another way, and that is to apply a small force, but do it over a very long period of time. And the longer the time that you do it, the greater the velocity changes. And so having both of these things on the same side of the formula actually makes it really good and really useful, because they are both very important for changing the velocity. And I think it makes sense to you. Back in the old Apollo days, a lot of thrusters were either on or off. They weren't that you could change the force that they applied. So instead, you have to change how much time you applied that force for. And so you can see that the thrust that was applied was actually a result of both of those things, not just how much force was applied, but also for how long it was applied. And so when you put those two things together, you get this new concept, and this new concept is something we're going to call impulse. Impulse is one of those words that I think a lot of people don't really get, because impulse is something that is a word that we use in regular everyday life. Impulse means like I did something without really thinking about it first. In this case, obviously, it doesn't mean that. It means the product of the force and the time. So impulse is really the thing that changes the velocity of an object. So why do we have mass and delta v over there? Well, believe it or not, these two are related too, in a kind of a special way. Mass is a way that we measure how much inertia something has. Inertia, if you recall, is the resistance to a change in motion. So again, mass is a way of talking about how much things are resisting changes in motion, and then delta v is the actual change in motion. And so they are very closely related. Now, when we put these two together and by multiplying them, we end up with a very interesting concept, which we're going to talk about a little bit more in the next video. It's actually the change in momentum. And we're going to talk about momentum. Oops, apparently I can't spell. Momentum, we're going to talk about in the next video. It's a very important concept that has to do both with the mass and the velocity, the resistance to a change in motion, and how much the motion actually changes. And so this is a change in momentum. Now the impulse, you can see, and the change in momentum are exactly the same numbers. They don't have the same units, though, so that we have to be careful about. So I'm going to go over that in just a minute here. Okay, so here we are where we're going to start talking about impulse. So first off, we can set impulse aside from this formula if we wanted to. This is technically called the impulse momentum theorem, or the impulse momentum relationship in our textbook. We can get just the impulse out of it and set it aside as if it's its own thing, which we're going to do a few times in this class. Impulse is equal to, as we said, the net force times the time. Now you may notice that I wrote a J here, and that's not a mistake. J is impulse because we already used the capital I for something else, and we already used little I for something else, so we can't use impulse, we can't use the I for impulse. So we have to use the character that's most closely related to I, and that's the J, right? So it's a very similar looking variable. And so we use J for impulse. At least that's why I think we use J. Makes sense to me. So J is the impulse, and it's equal to the net force times the time. So let's look at what the units are for it. Well, net force has the units of newtons, and time has the units of seconds. And so the units for net force, or for impulse, pardon me, are newtons seconds. No tricks there. It's pretty straightforward. There's no fancy name that we associate with it. It's just Newton seconds. That's it. Hopefully that makes sense. So why is the impulse important? Because the impulse is the thing that changes the velocity. I assume in this case that the mass is pretty much always constant. So I'm not worried too much about that. So the impulse doesn't often change the mass of something. What it does change, though, is the velocity. And so if you want to find out how much the velocity changes, you can use the impulse to be able to do that. And that's what we're going to explore this week. Hopefully this makes sense. If you have any questions, please let me know. Thanks.